What's up YouTube? My name is Christopher and I'm from Dr. Story's physics class. And today I will be explaining capacitors in a circuit. So I've drawn a series circuit here. If you can see that, I've got 4 microfarads, 2 microfarads, and 15 volts on this circuit. First we're going to calculate the equivalent capacitance throughout the circuit. And since it's in series, it's invertedly added. And so this is our formula. And so we will take 1 over 4 plus 1 over 2 to find the equivalent capacitance in the circuit. And so when we first add 1 over 4 and 1 over 2, we will get 6 over 8. You can plug that in your calculator if you'd like to. And then we flip it so that we get 8 over 6 which results in 1.33 microfarads. Now that we have our equivalent capacitance throughout the circuit, we can use this to find the equivalent charge. To find the charge, we multiply capacitance times voltage. Since we have a voltage of 15 and we calculated 1.33 for the capacitance, we multiply that and that'll get us 19.95 microcoulombs. In a series circuit, the charge is equal throughout the entire circuit. However, the voltage is not. If we want to find the voltage at a given capacitor, you take the charge and divide it by the capacitance. So I'm going to start with the 4. And we'll do 19.95 over 4, which will give us 4.9875 volts. Then we'll do the same thing for the 2 to find it. And that'll give us 9.975 volts. And if you add the voltages together, they should come close to 15 volts. Since I rounded this 19.95, it won't be exact. Next we're going to move on to a parallel circuit. So in this parallel circuit, I've got 7 microfarads at the top, 3 microfarads in the middle, and 15 volts towards the bottom. To calculate the equivalent capacitance, all we have to do is add the 7 and the 3 and we'll have it, which will give us 10 microfarads. In a parallel circuit, the voltage is equal across the entire circuit. So that means that the voltage will be 15 through each capacitor. With this we can find the charge on each capacitor. So to find the charge on the capacitor with 7 microfarads, we multiply by 15, and that'll give us 105 microcoulombs. For the 3, we multiply 3 by 15, that'll give us 45 microcoulombs. And then, if you add these two, they should equal to the equivalent charge across the circuit. And so we'll find the equivalent charge across the circuit. Since we calculated 10 as the equivalent capacitance, we take 10 times 15, and that'll give us 150 microcoulombs. And if we take that 105 and 45 and add it together, that'll give us 150. So finally, I'm going to draw a slightly more complicated circuit, and we're going to calculate the equivalent capacitance. So this is our circuit. The capacitance is all in microfarads. We have 4, 4, 8, 7, 7, 2, 6. And so to find the equivalent capacitance, we're basically going to break this up and try to simplify it. First, we're going to group these since they're in series. We add 1 over 4 plus 1 over 4. And that will give us 2/4. We flip it, and that'll give us 2. So with that, we can simplify the circuit. To 2 microfarads. Next, we're going to group these two and these two, because since they're in parallel, to try to simplify the circuit further. And since they're in parallel, all we have to do is add them. 8 plus 2 will equal 10. 6 plus 2 will equal 8. And lastly, we're going to add all these up in series. So we have 1 over 7 plus 1 over 8 plus 1 over 7 plus 1 over 10, and we can plug this in our calculator, and we should have 0.5107. We'll divide this into 1. And we'll get 1.972. Thank you for joining me, and bye.